All right, so now the next thing we're going to do is look at how data is laid out and compare the shapes of the data, comparing how it's distributed. Many of you already have this worksheet, so you're able just to fill it in. If not, use notebook paper just to write what I'm writing and fill in the blanks, and we'll do it in class. So the first question is looking to ask you is, how would you describe the shape of the data? So if we take a look at these different shapes, this one looks like it kind of has hills, this one's really tall in the middle, this has two different spots where it's really tall, so does this one. A lot of the data is down here for this one and it's not much up here. So it's just looking at how would you describe what the data looks like. Right, so distribution is described by a lot of different characteristics. So one of those characteristics is how it is spread out. So its spread is one characteristic. Where the center of the data is, that's another characteristic of how how the distribution is described. Okay, another one is symmetry. Right, the number of peaks helps describe the data. That's just like it sounds. That would have 2 peaks, for example. Direction of skew. Is the data skewed one way or the other? Direction of skew. And uniformity. How uniform is it? And the last thing would be any unusual features. Okay, so when you're comparing 2 or more data sets, it's important to focus on these characteristics. So when you are comparing these 2 data sets, or at least 2 data sets, if not more, it's important to focus on those characteristics to make your comparisons. Okay, so the spread of a distribution refers to what the variability or how consistent it is. So it's the variability of the data. Okay, the spread refers to its variability. So the values that measure the variability or how spread apart the data is. All right, so which values or what values measure the variability or how spread apart the data is. So the higher the variability, all right, the more spread it is. Well, I didn't answer that question, did I? What values measure this? These are things like your IQR, measure how variable it is, the range, and the big one that we've talked a lot about lately is the mean absolute deviation. The higher the mean absolute deviation, the more variable it is. All right, so the higher the variability, the more spread out the distribution is. So when it's graphed, it's more spread out, it's wider. The smaller the variability, the less spread the data is. Okay, so let's look at these 2. This data is all crunched up close together. This data is all spread out. So this one's going to have a smaller variability, where this one's going to have a higher variability. Okay, again, take a look at this one. Even though this is a taller peak, it doesn't spread out as far sideways. So this one has a lower variability, where this one has a very high variability. We do not care about how tall it is, how wide it is. Okay, of these 2, which one would be higher and which one would be lower? This is more spread out. This is going to have a higher variability, where this one would have a lower variability. Okay, so the center, graphically, the center of a distribution is the point where about half of the observations, half of the data are on either side. So it's the center is the middle, it's where it would be more like the mean of the data. All right? So what are the values that measure the center? All right, so these are measures of center. All right, there's 3 of them. They all start with M. Mean, median, and mode. Okay, so the shape of a distribution is described by 4 characteristics. Okay, symmetry, the number of peaks, direction of skew, and uniformity. These came off that first list, but these 4 specifically talk about shape. Okay? So symmetry. A symmetric distribution can be folded at the center so that each side is a mirror image of the other. Okay? And it doesn't have to be an exact mirror, but really, really, really close. So like this one would be symmetric because I could fold it right in the middle. This one would be symmetric. This one, I can't fold this right in the middle and it's the exact same on either side. So that's called asymmetric. When they are not symmetric, they are called asymmetric. Okay? The number of peaks. Okay, so distributions can have very few or very many peaks. A unimodal, okay, distribution has it's a distribution with one clear peak. Sometimes it's called bell-shaped. You ever heard of a bell-shaped curve? That's what it's referring to. So like a unicycle, 1, is one clear peak. Bimodal has 2 clear peaks. Unicycle, bicycle. 1, 2. Bimodal has 2 clear peaks. So this one has 1 clear peak. Okay? So this is going to be unimodal. This has 2 clear peaks. It's bimodal. Direction of skew. Some distributions have many more observations or data on one side of the graph than the other. Okay, that's going to be skewed. So this one, when it's not skewed and the tallest point's in the middle, that's called a normal curve. Okay, this one, the data is all the way over here to the left, but it's kind of an opposite thought. This is called right skewed. And this one is left skewed. It's kind of the opposite of what it looks. And the last one's the uniformity. Okay. So when observations in a set of data are evenly spread across the entire distribution, it is called uniform. Okay, a uniform distribution has no clear peaks. This data goes evenly across all of the numbers.